So hey all, today we'll be discussing the problem of the day, that is insert in a sorted manner in a sorted doubly linked list. So let's see the problem statement. Given a sorted doubly linked list and an element x, we need to insert an element x into the correct position in a sorted doubly linked list. So we are given a sorted doubly linked list and we have to insert an element. We are given the value of a data of an element and we have to insert that element as a node in the sorted manner in that sorted doubly linked list. Okay. So, and the sorting is done in ascending order. So we have to make sure the sequence is in ascending order. Okay. So let's look at the problem. Let's look at the code and implementation together. So if, so we have taken a node. Okay. So we have taken a node. Uh, so we are creating a new node that is named as root. So we are naming it as root. You can name it anything. So, and then we are placing the data, okay, the root of data, since we can see the structure of node is like it contains a data element and the previous and the next element. So we are setting the data part of our newly created root node is equal to x, which means that it will store the value of x. Now look at the implementation. Let's say we are given a linked list. Let's say we are given a linked list like this: 2, 3, and 8 and 10. Let's say we have to insert an element whose value is 1. Okay, x is equal to 1. So how will we insert it? So first we will look at the first element, that is the head element. Okay, so this is our head element. Now we will check whether if the value of x, okay, is lesser than head or not, the value and the data of the head or not. If it is, then what we are doing is we are just creating that root node. This was our root node, and then what we are doing is we are placing the next pointer of this will point towards the head, and the previous pointer of this will point towards null. Okay, so the previous points towards null. Okay, so it points towards the null, and the next pointer will point towards this node. Okay, because it's a sorted doubly linked list. Okay, so right now here for simplicity, we are just assuming that we are assuming we are just denoting it as a single list. Okay, so this will be the first edge case. Okay, the case one. Okay, so you have case one. Okay, when the head is greater than the current element value, then we will insert. Then we will and that's what we are doing. So if x is less than the head of data, then what we are doing is root of previous, our newly created root node, the previous of that node will be null pointer, nothing before head. It will be a new head basically. And root of the next of them will point towards the head. Okay, and then we'll simply return the root. Now let's talk about another test case. Okay, so we have seen this case. Let's say now. Okay, so now let's say we have an element of 6. Okay, so we have an element of 6. Now what we are doing is we are just traversing the array. Simply we are traversing the linked list. Okay, so 2, 3, and 8 and 10. So we will check whether the 2 is greater than 6 or not. It's not. So we'll move here. Okay, 3 is greater than 6 or not? No. 8 is greater than 6? Yes. So 8 is greater than 6. The previous of 3 was 3. Okay, the previous node contained a value of 3. So if it's the first element that is greater than 6, what will be the previous element? It will be the largest element smaller than the x value of x. Yes or no? So this will be our t. Okay, we are representing as a t. Okay, that's what we're doing here. So that's what we're doing here. So we are traversing the linked list. Okay, at first we are setting the value of t as head. Then we are just simply traversing, and we are checking if the t of next of data is lesser than x, and t of next is not equal to null. Okay, till then we will simply move, and when this condition fails, we will be arriving at our last element. Okay, this will be our t here in this case. Okay, because the t of next will be greater than 6. Okay, so we want this node. Okay, you can use this because it's a doubly linked list, so you can also use this. Okay, now what we are doing is we are simply, okay, let me make it fit. Okay, so we create a new node that is of x. Now the next, so we'll store the next of 3, because if we don't store it, we'll miss out. Okay, we'll forget. We basically this will disconnect the entire linked list. Okay, so we'll first storing this t dot next in a last variable. Okay, so t dot next we are storing in a last variable. So now the next of 3 will point towards 6. The previous of 6 will point towards here. The next of 6 will point towards where? 8. Okay, and 8 will be stored as the last. Okay, as the last node, the pointer to the last node. Okay, and now we'll have this the previous of this last. Okay, we are denoting this as last. Okay, the previous of this will be storing the value of 6. Okay, so here, so the previous will point towards the node with the value of 6. The next will point towards the node with the value of 8. The previous of 6 will point towards the node with a value of 3, and the next of the node with the value of 3 will point towards the node with the value of 6. Okay, and we will simply break this because we are just, first we will store this last. This is the last, and then the next, that's what we are doing. So we are doing this root of previous is equal to t. Okay, root is the newly created element, and the t of next is equal to root, which means that the t of next, that is 6, okay, will be equal to root, our newly created element. This is our root element. Okay, this is our root element. Okay, this is our root element. Now, so now we have got this. Now let's say there is another element that we are adding. Let's say we are adding. Let's say we are adding of a number like 12 greater than the last element. Okay, last, I mean the last of this list. Okay, so let's say we are adding this. So let's say we are adding a node. So you have a node of this. Okay, now the previous of, now this will be a root node, the current root node. Okay, now let's say now the previous of this root node will point towards 10. Okay, so the previous point towards node. Okay, this will be our t. This will be our t. Now the previous of the root with the value of 12 will point towards the node with the value of, the next of 10 will point towards 12. Okay, but now, okay, now if we look at the last of 10, what is the last? Last is equal to null, because t dot next, this is our t. What is the next of t? This is null. So we have null as our last element. Okay, now the last, we have its t. Okay, what is the, now since it's a null node, what is the previous of it? It doesn't have any previous or next. Okay, null doesn't have any previous or next. So we'll look for this edge case. The edge case is if last is not equal to null, then only we will assign this previous and next. Okay, and simply for the next value of 12, we can simply say it is equal to this, and we will break this. Okay, so the next of 12 of course will be null, so will assign this, and the previous of null, there is no such thing as previous of null or the next of null. So that's what we are doing. So we have done this operation, but we'll make sure that if last is not equal to null pointer, then only we will update the previous value of the last pointer that we have. Okay, then only we will have it. Okay, so let's see the time complexity. So time complexity of this algorithm is, we are simply just traversing the array. We are simply traversing the linked list. Okay, so time complexity is big O of n. What is the space complexity? We are not using any extra space. We are just using some variables, pointer variables. So big O of 1. So this is time complexity big O of n, and space complexity will be big O of 1. This is how we solve the problem. Thank you.